Now that we're comfortable verifying trig identities and simplifying trig expressions, we're going to learn one more new thing with our identities, and that is trig substitution. So if you take a look at the first example, we're given a value for x that we are going to substitute under the radical and then simplify. If you take a look at what's under the radical right now, we do have two perfect squares, but because it's addition, we cannot further simplify that. However, if we replace the x with our 2 times tangent theta, we can get this expression more simplified. So the first thing we'll do is square each of those two pieces. We're going to square the 2 and the tangent. And then both terms have a 4, so we're going to factor the 4 out, leaving us with 1 plus tangent squared. Remember, when we factor, we're dividing. So when I factored the 4 out of the first term, I had a 1 left over because I divided the 4 by 4. Now we can use a Pythagorean identity to replace 1 plus tangent squared with secant squared. And then we can take the square root of each piece. The square root of 4 is 2, and the square root of secant squared is secant theta. We're going to run through a similar process a couple of more times. So our next one, we have replacing x with 2 secant theta, and then subtract the 4, squaring the 2 and the secant. Again, we have a 4 we're going to factor out, leaving us with secant squared minus 1. Pythagorean identity, secant squared minus 1 is tangent squared. And then we can take the square root of each piece. The square root of 4 is 2, and the square root of tangent squared is tangent. One last substitution example. Replacing our x with 2 cosine theta. Just the x, don't replace the 16. And then we'll square each of those pieces that are inside the parentheses. Again, not the 16, it's not in parentheses. So we get 4 cosine squared. Multiplying the 4 and the 16, we get 64. So now we'll factor out the 64, leaving us with 1 minus cosine squared. This Pythagorean identity is sine squared. So we have 64 times sine squared, and then we'll take the square root of each piece, giving us 8 times the sine of theta. This next example, we've done something similar with this by setting up right triangles and solving for the missing trig functions. This time we are only going to use the identities we've been given to solve for the other 6 trig functions. So first of all, I like to use a Pythagorean identity, so I know that tangent squared equals secant squared minus 1. So I'm going to replace secant squared with the value that I gave you, that negative 3/2, and then I'll solve for the tangent. First of all, squaring the negative 3/2, I get 9/4, and then I will need a common denominator to subtract my 1, so I'm going to multiply by 1 by 4 over 4. So tangent squared is 5/4. Taking the square root of both sides to get tangent of theta, we get the square root of 5 over 2. Now we need to check which quadrant we're in to see if the value of tangent is positive or negative. Up here in the directions, we were told that tangent is positive and secant is negative. Secant is the reciprocal of cosine. So if cosine is negative, we're in the 3rd or 4th quadrant. And for tangent to also be positive, we would need to be in the 3rd quadrant. So that'll help us find the signs on all of our other functions as well. So we know tangent is positive. We can use the reciprocal identity to get cotangent. So we would have 2 over the square root of 5, but we need to rationalize that. So I move the radical to the numerator and drop it in the denominator. We can use the reciprocal identity for secant as well. Secant we knew was -3/2. The reciprocal of secant is cosine. So cosine would be -2/3. And then we can use another Pythagorean identity to solve for sine. Sine squared equals 1 minus cosine squared. So we can substitute in that cosine value, which was -2/3. So we get 1 minus 4/9. Getting a common denominator, our 1 turns into 9/9 minus 4/9 gives us 5/9. And then to solve for sine, we'll take the square root of both sides. So we get positive or negative square root of 5/3. Remembering that we are in the third quadrant, sine is also negative in the third quadrant, so we know that our sine value would be a -5/3. And finally, we'll find the reciprocal of sine, which is cosecant. So that gives us -3/5. Rationalizing, we're going to bring that radical up to the numerator, -3 squared of 5, and drop it in the denominator.